is we left off last class talking about elasticities. I put up the next kind of Pearson kind of homework. So looks like homework number 2. So a lot of the questions we haven't worked through yet. And that tentative exam date, which was originally next Friday, I'm probably going to push forward a week. So not until October 1st. Right? I said it's, sometimes I'm a little overzealous in setting those dates. I'll never kind of make them earlier, only further. So kind of push that exam up a week. Get a couple of weeks to finish the material. Give you enough time to kind of work on that second homework, which will be kind of a nice preparation for that exam. And then that exam week that ends in October 1st, we'll probably be able to do at least 1, if not 2 class periods of a little bit over a week. Okay? So I'll be getting some practice exams together and up this weekend. But as you start working through that homework, right, there's going to be some elasticity stuff. There's going to be some equilibrium stuff that I'm going a little bit out of order. So we skipped it, but I'm going to come back to it, maybe even at the end of class today, if not in the class today, for sure on Friday. Okay? Any questions from me before we kind of get going? Okay. So we started talking about things that might influence the elasticity of a good, right, or the elasticity of demand. So remember, elasticity, if something's elastic, it's responsive. Responsive to what? Well, we're thinking about the price elasticity of demand. So the responsiveness of demand to price, right? The price changes. So I think last class we went through, I talked about the availability of substitutes, right? If we have more substitutes, right, we can kind of substitute away from the current good if the price gets too high. More substitutes are available, the more elastic a good's going to be, right? Kind of vice versa. If it doesn't have many substitutes, right, it's going to be less elastic. We then said kind of proportion of your income. If a good makes up a really high portion of your income, you might be really responsive to price changes, right? Think about this, we're talking about with elasticity, not just the change in price and the change in quantity demanded, but the percentage change, right? So something like a house, right? If you see the price of a house, a $200,000 house go up by $10,000, that's not a very large percentage change, but because it makes up a high portion of people's incomes, they might be really responsive, right? They might choose not to purchase that specific house at $210,000, even though it was a relatively small percentage change. Right? But if it makes up a small amount of our income, like a pack of gum, right? It doesn't matter if we see a huge percentage change, right? $1 to $2, that's 100% change, right? Well, it makes up a small portion of income. I might still buy that same number of packs of gum or whatever that small kind of ticket item is. All right. So we had one more that we didn't have time to talk about, but I think it's pretty intuitive, right? Which is the length of time you have to make the purchase decision, right? So if I have a good that I am kind of in a bind for, right? I'll give you like the most extreme example. Right? My brother's allergic to like a couple different things, but still tries to eat them, like shrimp and avocados and stuff. So one time, he takes a chance, gets some sushi and had some shrimp in it. He ran across the street to the gas station, flung the door open, grabbed a bottle of Benadryl, right? He didn't care what the price was at that point in time, right? He needed that Benadryl right away, right? So if the length you have to make the decision, he can't shop around for the lowest Benadryl price, right? So it doesn't matter if he saw price changes, his responsiveness would have been pretty much zero. He would have bought that bottle of Benadryl regardless, right? So the length of time you have to make the decision is short, you're going to not be able to be as elastic, or the less time you have, the more inelastic, right, or unresponsive you'll be. Now, if I have a lot of time to make a decision, right? So, for instance, if you're thinking about purchasing a new car, right, but you don't need it right now, right? Your current car is fine. You just got enough money that you can upgrade. You're going to be a lot more picky when you're walking around a lot. You can take your time, shop around for the best deal, especially if you're looking for a used car. Maybe look at things that are a little bit further out. Make sure you visit every single dealership. So if you've got a lot of time to make your decision, you can be a lot more responsive to higher or lower prices. Right? So the longer I have to make a decision, the more elastic or more responsive I can be. So more time, I can be more elastic, right? I have more time to make my decision and try to find a cheaper price. Less time, right? I don't have any time to go find a similar substitute. I need this now, and so you can jack the price up right now, and I'm still going to need to buy it. Right? This is actually kind of similar to the idea of how do people try to exploit this? So if you know that, so we'll use Texas. So when they had that big snowstorm, right, and all their power got knocked out, they knew that the people, if they wanted power, like a generator to power their house, that they didn't have a lot of time, right? They needed it right now. And so what happened to the price of generators in that area? Jacked them way up, right? They knew that people couldn't be responsive to price changes, right? They knew they needed that right now, and so they couldn't wait another month or two. It wouldn't have, they didn't need a generator at that point, right? So kind of less time makes things less elastic. Sometimes we'll see, I don't want to say unscrupulous companies, but companies trying to make a quick buck kind of exploit that. Any questions on this? We've got these things that we know might factor into kind of the elasticity of demand. All right. We looked at this briefly at the end of last class and kind of think about some of these different goods. And all these factors will play a role in what the ultimate price elasticity of demand is. But with all these factors incorporated, we can see that there's some things like new cars. If you're thinking about going out to eat at a restaurant, these are fairly elastic, or maybe a lot more responsive to price changes. If I know that a certain restaurant has increased their prices by 20%, or I might be more likely to try to substitute a way to go to a different restaurant. Relatively inelastic, right, would be things like if I need a airplane ticket, but I need to be somewhere tomorrow, then you can really see that time to make the decision really influences the elasticity there. That people are really inelastic. Inelastic being less than 1, like we said last class, and then elastic being greater than 1. I think I had some other goods here too. I thought there was a couple that were maybe. Oh, I went out and grabbed a bunch of elasticities of different beers. So this is kind of interesting. Like when you get down here to things like high strength premixes, like basically just like a pre-made mixed strength, they're all trash. So people are really responsive to price changes. Like I'm not going to pay a higher price if this is already kind of a low quality product. And so you see that people are really greater than 1, pretty elastic when it comes to things like that. When you have just more general categories, like in this one, maybe you're a beer snob, but every stout tastes like a stout to me. Like they're all just like so dark and deep. And then you move your way up and you start to get things like single malt whiskeys. Well, you can't really, there aren't as many substitutes for a really good whiskey. And so you see people be a little bit less responsive. Doesn't matter if you increase the price by 20%, they're probably still, if they want that expensive whiskey, they're probably still going to buy it. Right? So kind of interesting that even within a product, this is I wanted to bring this one up to point out, right? Every market, right, we're looking at, we were thinking about it as a perfectly competitive market and that the goods are homogenous. So even within the category of like alcoholic drinks, right, there's going to be a lot of different types of products. So actually what we want to do is not look at the elasticity across all alcoholic drinks, but we could probably break it down to make sure that we're only looking at kind of homogenous products, right? Maybe for some people, right, beer and liquor, there's not a substitute, right? So kind of interesting to see that even within categories, we really have to focus and kind of define that good, right, down to be pretty specific, because everything we've set up assumes this homogeneous product. So I talked a little bit about this last class, but elasticity and slope are not kind of synonymous. However, we said we can think about that generally, the steeper a curve is, kind of the more inelastic it is. We could see huge price changes. The quantity demand might not change much. So I think last class we looked at perfectly elastic and perfectly inelastic goods, kind of a perfectly inelastic good being a vertical line, right? And where it doesn't matter what the price is, people buy the same amount, right? So huge percentage changes in price lead to no change in percentage quantity demand. And then we had the horizontal kind of demand curve, which would reflect perfectly elastic goods, where even if the price stayed the same, right, we might see that there's a percentage change in the quantity demand. Right? So the flatter a curve, generally the more elastic, the steeper the curve, generally the more inelastic. So I think we talked about this last class. However, right, along the same demand curve, what we'll actually find is that elasticity varies. Right? So I think that pre-class video, I kind of went through an example. I showed you how do we use values on a demand curve to actually calculate elasticity. And I think that before we go to this example, I'm really going to try to highlight this idea that the elasticity of demand is going to be very different along different points of the domain. I don't know if I'll work out all of the math exactly, but I'll give you some kind of intuition. Right? So I've got demand with plus this marginal benefit. Maybe right down here, make it real easy. Okay? And right here, we'll be at 9. I can't remember if I did this last class or not, but if I did, it's good to see. So notice that when I'm up here, I'm thinking of moving from here, this point to this point. Okay? Well, the price went from 10 to 9. That was a relatively small percentage change compared to the quantity demanded went from 0 to 1. And that was a really large percentage change, right? If I start out at 0, even if I went up by 0.01, that's an infinite percentage change. I'm not thinking about kind of using this midpoint method, which is what we'll be doing, right? But regardless, you can see here that the percentage change in quantity demanded, right, is going to be much larger than that percentage change in price, right? Well, if that's the case, then our elasticity of demand, we'll move out of the way here in a second. That was our equation. Well, if the numerator is greater than the denominator, then this has to be greater than 1, or up here, we could say that we're on an elastic portion of our demand. Well, let's think about if we're on the same demand curve, but we went from a price of $1 to 0, right? So moving from $1 to $0, the quantity changes from 9 to 10. Well, there you would have the percentage change in quantity demanded, right? Roughly a 10% change, somewhere above there. Using the method, we'll find it's a little bit different, but around 10%. But the percent change in price, well, the price decreased by like 100% or infinite percent, really 1 to 0, right? So a huge percentage change in the price. So now I'm thinking about my elasticity of demand. It's going to be what? What can I say is true about the elasticity of demand here? Huh? It's inelastic. So it's going to be inelastic because now my numerator is smaller than the denominator, so I'm going to end up with a value that is less than 1, right? 2 divided by 4, 20 divided by 60, right? Whatever those percent changes are, I know that the numerator is less than the denominator, so it's always going to give me a fraction less than 1. Or, as you correctly said, right, this is going to tell me that down here, I'm on the inelastic portion of my demand. And it kind of makes sense, because when I'm looking at smaller prices, even the same level change, right? Price still went down by $1 here, but when my base is 1, that change of 1 is a huge percent. When I'm going from 10 to 9, still a change in price of 1, but my base is a lot higher. So it's a smaller percentage change. So generally for every demand curve, you can think about for the price values that are higher, that's where demand will tend to be more elastic. As we start to look at lower prices, that's where we see changes in price are going to start to look a little bit more inelastic from that demand. And that's always the case, kind of moving from left to right or up to down, right? The elasticity of that demand curve is getting smaller and smaller as we move to the right or kind of to lower prices and higher quantities. Okay? So I have some different values here. We could go through and actually calculate. I've got some to plug in here. So if we looked at the change in price here, 30 minus 20, divided by the average price, so 30 plus 20 divided by 2, we'd see that's a 200% change kind of in price. Sorry, it's not 200% change in price. It's a 40% change in price, right? And if we look at the quantity demanded going from 0 to 20, using that midpoint method, we would take the difference, so 20 minus 0, divide by the average, 0 plus 20 divided by 2, so 20 over 10. That gave us a 200% change in quantity demanded. So might be good. I know we worked through the midpoint method a little bit last class, and then that video I had, I went through some. It might be good on your own to try to reproduce these numbers. I don't have them written out, like calculating the changes, but these are the numbers you should get if you went through and used that midpoint method. So that might be some good practice as well. And then I could go down here, do a similar thing between the prices of 10 and 20, right? My quantity goes from 20 to 40. Now when I calculate my percent change in price and quantity, we'll notice, and you kind of can picture it, but like 10 is half of 20, 20 is half of 40. I end up actually seeing the same percentage change, which when I have an elasticity of 1, I would say that the good is what? Remember from last class? It's not elastic or inelastic. We say that it is unit elastic. Basically that for every change in price, it's like 1-to-1 change in quantity demand. And then if we want to use that midpoint method to calculate the values down here, we end up with a relatively low elasticity, or we would say that that portion of the demand curve is inelastic. So same kind of thing ended up on the board, right? You just have some actual values you can kind of go back to and check. But as we move kind of down, I guess that demand curve, it always becomes more inelastic. So part of the video was calculating some of these elasticities, right? And I said something specific in the video, right? And the example kind of want to show, and I'll try to lead you a little bit even if you didn't want. So let's say we've got what? When demand is elastic, right? If I change the price, so if I decrease the price here, right? And demand is elastic, what's going to happen to my total revenues? So if I've got demand that's elastic, it's very responsive. Right? If I change the price, right? If I decrease the price, what's going to happen to total revenue? And total revenue is simply going to be this price times quantity. So if I'm decreasing the price, that's going to decrease total revenues. But when I lower the price of a good, I sell more of them. So that's going to increase quantity, which will increase total revenues. But what's going to happen overall if I know that demand is elastic? So that decrease in price, whatever percent change that was, if it's an elastic good, I know that the percent change in quantity demand would be greater, right? So kind of thinking about what would happen to total revenue. Once I get everyone in here, I'll probably be nice on this one. Okay. Notice it's still open. You can always change that. So if I see that, think about it this way. This isn't mathematically a perfect way to look at it, but I think the intuition will wake up. Let's say I see a 10% decrease in price. So that's going to lower my total revenues. If demand is elastic, what do I know the percentage change in quantity is going to be? I don't know the exact number, but I can say that it is, demand is elastic. That means that my fraction is greater than 1, right? The only way this fraction is greater than 1 is if the percentage change in quantity demanded is more than the percentage change in price, right? I'm being overly responsive. Price changed by 10%. I change how much I bought by 20%. Right? I'm very responsive to that price change. So if I know that demand is elastic, that 20% change in price will be met with a percent change in quantity demanded that is greater than that, right? Choose your number just to prove this to yourself. But like, let's say it went up by 15%, right? The quantity demanded. Well, price decrease of 10%, that hurt total revenue, but the change of the increase in quantity demanded, right, more than compensated us for that. So it's almost like, well, yeah, here was a decrease of 10%, but if I gain 15% from quantity, I'm like net positive of 5%. So in this scenario, because the percent change in quantity demanded was greater than the decrease in that percent change in price, I know that total revenues will overall go up. Okay. So if you're paying attention at all, this one should have been really easy. Make sure everyone got kind of their answer in here. Okay, 35 of us will kind of use that number moving forward. Are there any questions on it? Is that kind of making sense? You know, we would have the exact opposite be true. Let's say it was inelastic. Well, I know that If it's inelastic, this percent change in price has to be what relative to the percent change in supply and demand? If it's inelastic, the elasticity is less than 1. So if it was a 10% change in price, what could I say about the percent change in supply and demand? Has to be less than that, right? So choose your number, right? Maybe it's 5%. Well, now that decrease in price kind of hurts total revenue more than that increase in supply and demand did. And so now if I'm on an inelastic portion and I decrease the price, I'm actually going to decrease total revenues. So that's kind of the intuition behind why. But I've got, I think here, maybe, there we go. Right. Yeah, so why do we care about this elasticity measure? Well, if I'm a company, right, and I'm thinking about changing, increasing or decreasing the price of my good, I'm going to do that hoping that I can change my total revenues, right? If I start to change the price of my good and then that decreases total revenue, I'm probably getting fired, right? That's not a good thing. So this is why we're concerned with what the elasticity of demand is, right? And ideally what we would do is we would like continue to lower this price until total revenue is at its highest, right? When I had the example where demand was elastic and I decreased the price and it increased total revenue, well, I'll keep decreasing the price as long as it's still elastic, right? As long as it's still increasing total revenue, right? And we already walked through kind of how it's influencing that total revenue through price and quantity, right? Kind of almost like simultaneous changes. But I'm going to go back to a slide. So with this idea in mind, right? As long as demand is elastic, if I'm decreasing the price, we said that's increasing total revenues because those price decreases are going to be overcompensated for in large percent change or increases in quantity demand. Right? So I continue to lower the price as long as it's still elastic. But if I'm looking at this demand curve, and remember I said, as I move to the right, as I continue to decrease the price, what's happening to that demand curve? It's going from being elastic to inelastic. Well, once I get down, I keep lowering the price, and I get down somewhere like here. Well, now if I keep lowering the price, we said if it's inelastic, that's now going to decrease total revenue. So I don't want to keep lowering the price once demand becomes inelastic. So what am I going to do? I'm going to continue to lower the price up until I hit this point where it's exactly unit elastic. Because then every percent change in price negates the percent change in quantity demand. There's no change in total revenue. So I'll continue to lower the price when demand is elastic up to the point where I'm unit elastic, and that's where total revenue is maximized. Because if I continue to lower the price past that point, I'll be on an inelastic portion of the demand curve, and I'll start to decrease my total revenues. Okay? So that's kind of the intuition behind that. We can actually look at the numbers, right? And these are really easy kind of toy examples. But right, all I did here was look at different price and quantities, right? As I lower the price, right, I can calculate what total revenue is. Okay? I also calculated the elasticity to kind of prove to you that this holds, right? So if I'm moving from a price of 5 to 4, right? And here I didn't take the absolute value, so I just left the negative signs on there. But if we took the absolute value, we can kind of think about this. I think it's a little bit easier. But here we've got something that's, if we took the absolute value greater than 1, so we said that would be elastic. So as I lower the price here, I'm on an elastic portion of the demand curve, total revenue should go up. Sure enough, if I lower the price from 5 to 4, total revenue, 5 times 0 is 0, goes to 4 times 1 is 4. So total revenue has went up. If I then lower the price from 4 to 3, well, total revenue before, 4 times 1 was 4. Now it's 3 times 2, which is 6. I was on an elastic portion of the demand curve, right? It was an absolute value, it was greater than 1. So as long as I lower the price here, my total revenues were going up. If I then lower the price from $3 to $2, notice if I compute the elasticity between those 2 points, it's exactly an absolute value would be 1, or we're unit elastic. So this should be the point where total revenue is maximized, right? It doesn't change, right? If I increase the price at this point, sure enough, 3 times 2 is 6, 2 times 3 is 6, total revenue hasn't changed when I lower the price here at the unit elastic point. But if I continue to keep lowering the price and I go from $2 to $1, well now 2 times 3, a total revenue of $6, 1 times 4, total revenue of $4. Notice when I'm on an inelastic portion of that demand curve, lowering the price, actually starts to then decrease total revenues. Okay, so you can use some kind of numerical example to prove this to us ourselves as well. And I haven't done this a lot. Like I said, we might do this at the end of class today or start with it on Friday. I'm going to start showing you kind of the equations for demand, right? So that's kind of where these numbers came from. Right? If I plug in a price of $3, 5 minus 3 would be a quantity demanded of 2. Right? That's kind of how I produce these numbers. There's an actual formula kind of floating in the background for what demand is. Right? And that was the idea we talked about, y or price equal to A plus B times quantity, right? That value A, or the intercept, would be where our demand hits that y-axis. And then the slope of our demand curve, that represents kind of that B, right? The value is going to be in front of quantity here. It's kind of a weird one, right? If we rearrange this, the value in front of quantity would be actually 1, right? So that's why we don't have another numerical or another number up there. But I'll go into that more in detail later. So I kind of color coded these so you can kind of see, all right, moving from this price to this price, demand was elastic or inelastic, and what happened to total revenues. All right. So we know that revenue is related to the elasticity, or at least that the elasticity of demand, the price elasticity of demand, influences what happens to total revenue as we change price, right? So, generally what we think about is on the left side of our demand curve, the higher prices, that's where we're elastic. So when prices are high, it kind of makes sense to lower the price and we'll increase total revenues. And that kind of makes sense. If the prices are higher, like not many people are going to purchase it. So if I can kind of lower the price there, I'm going to gain, right? But at some point, when the price gets low enough, right? Well, yeah, I'm going to sell more units, but not that many more, right? So I've got kind of this inelastic portion of the demand curve over there on the right-hand side when prices are low. And so then it doesn't make sense to lower prices. So usually, we're going to be somewhere kind of in the middle, right? And exactly where that's at is wherever that unit elastic point is at. So another visual of this relationship between elasticity and total revenue, and then I'll kind of draw another graph that I think kind of connects them pretty well, is let's say I am decreasing the price from 4 to 3, right? Before, when the price was $4, I only sold 1 unit. So you kind of think about here is kind of my total revenue. Well, by decreasing the price when prices were high, yeah, I lost out a little bit on that first unit, right? Because I was selling that unit before and I was making $4. Now when I lower the price, I'm only making 3. So kind of this orangish red area, I'm losing that, right? So I lost $1 on that unit I was already selling when I lowered the price. So I'm no longer selling it for $4, I'm selling it for 3. But by decreasing the price to $3, I got somebody else to want to purchase whatever, the latte here, right? So now when I sell that second unit, total revenues went up by those additional $3. Right? So I gained $3, lost $1 on that first unit, net positive of $2, total revenue went up by, oops, I want to go here. There we go. Total revenue went up by $2 overall, right? I lost $1, gained 3. Then if I lower it to $2, well, if I go from 3 to $2, notice on those first 2 units I was already selling, I lose $1 on each one. But lowering the price, I convinced someone else to buy a latte. I'm making an additional $2 on this third unit. Here, that was our unit elastic point. If we're going back to that earlier demand schedule, where the loss, my loss there kind of was equally weighted out by the gain, right, of selling this new unit. And then you can kind of imagine if I didn't move my arrow, but if you want to go from $2 to $1, I lose $1 on those first 3 units I was already selling, and I only gain $1 by convincing a 4th person to buy a latte. I lost 3, gained 1. It was on the inelastic portion of the demand curve. So when I lowered the price here, I saw that total revenue went down. Just another way of kind of visualizing this. Sometimes this connects with people a little bit more. Any questions over this before I go on to this next thing? Let me. Okay. We're ready for this. Let's say I've got, I don't know, to me this has always made sense, but I guess I can understand how it could be a little confusing. But I think it really kind of connects this relationship between total revenue and demand pretty well. And you could almost draw it more out of memorization than actual understanding, and maybe still kind of translate that message to you. So let's say I've got my demand curve. And I kind of think about, I'll break this down. We've got our, I want to really highlight this. So I've got my elastic. Let's say I've got just this single point where it's unit elastic, because I can look at not just like price changes of one, I can look at any price change I want. So I can look at a penny, I can make this really, really small, so I can really refine my kind of portions of demand that are elastic, unit elastic, or inelastic. So we always know this is going to be the way that our demand curve looks like. It starts out elastic, at some point becomes unit elastic, and then as we continue to move to the right, eventually becomes inelastic at these low prices. This is supposed to be a P. There you go. Just to kind of make sure we've got everything. All right, this is demand. What's going to happen is, if I draw the graph right below this, where I keep the x-axis the same. So I'm looking at the same quantities on this graph as up here. And up here, I'm going to think about total revenue, right, which is measured in dollars, right? Or just price times quantity. What ends up being true is that initially, right, if I'm selling 0 of something, how much is my total revenue? Well, total revenue was just price times quantity. So if I sell 0 of something, my total revenue is 0, right? So as I continue to lower the price, right, higher quantity will be demanded. But I also know that when I'm on the elastic portion of my demand curve, as I lower the price, so that lowering in price hurts total revenue, but demand's really responsive, so total revenue goes up by more than that from that increase in quantity demanded, right? The decrease in price hurts total revenue, but I know that when it's elastic, the gains I'll get from that increase in quantity demanded will overcompensate, right? So total revenue is going up. Right? If I can line this up right there. Once I get to that unit elastic point, I know that if I change the price from this point, right, and here I've got it to be really continuous, that's where total revenue should be maximized, at that unit elastic point, because their price changes didn't change total revenue at all. And then as I continue to lower the price, move along this demand curve, quantity demand gets higher, but now those decreases in price are causing huge or causing much smaller percent changes in quantity demanded, right? When it was inelastic, we knew that numerator was smaller. So when it was inelastic, that's where we started to see total revenue actually decrease as you continue to lower the price and sell more of the good. So this kind of, I think, helps you kind of line up a little bit. Where is total revenue maximized? Well, that's actually at the unit elastic point. Or, if we had the demand curve, we could determine where that quantity was at. Right? Maybe call this QTR, the quantity where total revenue is maximized. And then at any price and quantity to the left of that, right, you can think about, well, if I'm starting here, and if it's elastic and I increase the price, well, the increases in price will be good, but I know that people are really responsive, so they'll buy a lot less. And actually, if I increase the price, I'm moving to lower quantities, and at those quantities, the increase of price, I see a decrease in that total revenue. But if I'm on the inelastic portion, like let's say I'm at right here, I go down here, total revenue that lines up with. If I'm on the inelastic portion and I increase the price, I'm moving to a lower quantity, but at that lower quantity, I actually know that total revenues have went up. Right? So when I'm on the inelastic portion of the demand curve, I want to increase the price, which pushes me up to this maximized total revenue point. When I'm on the elastic portion, I want to decrease the price, which kind of pushes me to this maximum total revenue. Any questions on that before we keep moving? Just another way of kind of visualizing that relationship. Okay with that? No questions at all? All right. So, so we've got this relationship between revenues and elasticity. So hopefully, I've shown you this a couple different ways. Hopefully, we can start to think about this. I want to make sure that I'm not just getting no questions because people are afraid to ask questions. So I'll look at these after class and then I'll make a decision about what we're going to talk about Friday. So let's say I have cigarettes that are currently at a price of $4, right? And the company is considering increasing prices to $5, right? We think about where we're on the demand curve. Maybe we're at this quantity, the price is 4. We want to move to a higher price. Right? Currently, the elasticity of demand for that price that we're at is negative 0.4. Or if you want to think about the absolute value, we said we'll kind of think about that way, just a little bit easier to put the range to it. We'll think about the absolute value, elasticity of demand will be 0.4. Right? So it's less than that kind of cutoff of 1, which tells us whether or not demand is elastic or inelastic. So this price increase, if we've got an elasticity that's an absolute value less than 1, we should know what's going to happen to total revenue. So I'll give you a little bit of time to work through that. Like I said, maybe even draw a demand curve, draw something similar to that, and think about what a price increase would do. Remember, write down total revenue is equal to price times quantity. You know this is the elasticity. Think about, okay, was the percent change in price or the percent change in quantity going to be larger? Whichever one's larger, that's the one that kind of dictates what direction total revenue would move. Several ways to think about this. Right? So I'll give you a little bit of time to work on that, and we'll kind of come together and try to review it. Okay. Yes, you can talk with people around you, work with people around you on this. All right, looks like most of us have an answer in. So if you don't have an answer in yet, take your best guess. I'm going to close this out here. Okay. So, all right, the ultimate answer is that revenue increases. Right? But why do we know that's going to be the case? I mean, I have a graph up here for you, right? If I've got an elasticity that's 0.4, an absolute value, that's less than 1. So I know that demand is going to be where? Elastic, inelastic, or inelastic portion? Inelastic. So I know I'm somewhere here. Choose wherever. I mean, I have it drawn up already, so I might as well use it. Let's say I was at a price of $4, and I wanted to move the price to 5. Well, I know that quantity demand is going to go down, but because it's inelastic, I said that increase in price, if it's inelastic, that means that denominator, the percent change in price, is larger than the numerator. So that percent change in price going up will increase total revenue, but the response from demand will be less than that, right? That numerator is smaller. So that decrease in quantity demanded will be relatively small compared to the percent change in price. So price going up is a good thing for total revenue. Quantity demanded going down is a bad thing. But the thing that was good, that percent change in price, we knew was greater than the thing that was bad, that percent change in quantity demanded. Only because we know that it's inelastic. If we didn't have an elasticity measure, we don't really know, right? But even if I couldn't think about that, if I'm moving the inelastic portion to a higher price, it's a lower quantity, total revenues are going to go up, right? So that's why I think being able to draw this sometimes helps you not to think through, the total revenue equation and percent change in price. So different ways of thinking about it. That's literally exactly what I just kind of had walked. So hopefully this one isn't too bad, right? If I had the same setup, right, $4 to $5, but now I said, actually, I calculated it wrong. I wasn't on the inelastic portion of my demand curve. I actually had a price elasticity of demand that in absolute value was exactly 1. So if we're at that unit elastic point and we see price changes, doesn't matter in which direction, we should know what's going to happen to total revenue, right? So when it was unit elastic, we said that this is the point where we knew something was going to be maximized, and that percent changes in price in either direction were actually small. Right? If I'm moving kind of infinitesimally away from that unit elastic point, we should know that something is going to happen to total revenue. This one's a little bit tricky. I kind of want to see the responses. I might actually end up being nice and kind of giving maybe an extra point on these iClickers today, since we're getting quite a few questions in. All right, we'll kind of do this one quick. So if you haven't gotten an answer in, I'm going to take your best guess here. 35 of us. All right. So what did we say is going to happen to total revenue at the unit elastic point? Yeah, it's going to be maximized, right? And through some of the numerical examples that we worked through, we saw that if I make infinitesimal changes in price from that point, that actually those changes in price, well, the percent change in price will be exactly the same as the percent change in quantity demanded. So they're always going to cancel each other out, and total revenue is actually going to stay exactly the same, right? So at that unit elastic point, price changes kind of either direction. Well, that percent change in price will be met exactly with the same percent change in quantity demanded, cancel each other out, and total revenue won't change. Now, in practice, it's hard to get, like, if we can measure things like at infinitesimally small kind of ranges, the unit elastic point is like, there's only a small, a penny on either side where we can actually do this and total revenue won't change. But if we're only able to observe things in like large portions of the demand curve, which sometimes is the case, right, then we might actually kind of have a wider price range. I kind of will skip this. We could do another one, right, where I switch this to make it. But what if we're on the elastic portion, then what would happen, right? That might be another potential question we could see kind of moving forward.
Am I just reading it wrong? Isn't it saying that it is unit elastic right now, and if they raise it to down?
So you're thinking about, actually, I think I have a sub-drawing. Right, if we aren't able to observe infinitesimally kind of small changes, like I can't observe every penny. Whoop, I'm going the wrong way. Right? There's kind of this idea that there's actually a range, right? If the only thing that I'm seeing parts of my demand curve, like I drew this line, but I don't observe, in practice, I don't observe every single price from 3, 299, 298, 297. And there might be this like portion of the demand curve that's unit elastic. So it's not specifically the one exact price, it's that the movement between $4 and $5, that whole portion of the demand curve is unit elastic. But I understand why it's hard, it's a conceptually kind of difficult thing. And for the most part, especially when it comes to the exam, I probably wouldn't ask a unit elastic question like that, because it is in the application not as practical. The practical application is we're usually on an elastic or inelastic portion of the demand curve. Now we need to think about how changing price matters. Yeah, if we're at the unit elastic point, right? Why do anything? If we know that, if we know we're there, we might as well just, Good question. All right. We're on time. 6 minutes. Okay, so I want to cross price. I think we'll kind of, yeah.
I still don't get why it wouldn't be this.
Right, so if you're between two prices, it doesn't quite line up with this as much, because it would be like if I told you, here's my demand curve, here's the price of $5, here's the price of $4. This portion is unit elastic, right? So it's almost like if I can't observe price changes at the penny level, I'm just observing that I'm moving it from $4 to $5, and that's where it's unit elastic. we think about total revenue. When I go from 4 to 5, whatever percent change in price that was, right? That would increase total revenue. Let's say that was a 10% change. I know that if it's unit elastic, that moving from that $4 to $5, the percent change in quantity demanded will be exactly the same, right? Looking about negative 10, but in the opposite direction. So moving from this price of $4 to $5, if demand is unit elastic, that increase in price, the benefit that total revenue gets from that is exactly offset by an equal response to consumers of buying less. That still not clearing it up. So I think the hard part to think about is if I can draw it, right? And I can draw it at the penny level changes. Yeah, I will have one, like, I will have two prices, maybe $2.99 to $2.98. That's where it's unit elastic. And if I charge $2.99 or $2.98, total revenue would be the same. We're breaking it down by dollar, just it's that same idea, it's just that it spans a wider range of potential values. If I was able to observe different prices like between 4.3 and 4.4, then yeah, I'm gonna be able to narrow down where that unit elastic point is a little bit easier. But using kind of the whole dollar amounts actually makes the computational a bit easier for you guys. I could break this down to like think about every single penny change. And yeah, then you wouldn't have to say moving from $4 to $5, like this is the unit elastic range. You could like really limit that range down. But we can kind of see it in some of those earlier numbers, right? When I had, what was it here? When I was moving from, there it is, $3 to $2, right? Similar idea, just moving instead of decreasing price on an elastic portion, I'm increasing price on an inelastic. So here, if I'm on the unit elastic point, going from $3 to $2, selling 2 units at $3 or 3 units at $2, that didn't change total revenue at all. Even though there's still different prices in that range, right? Moving from 3 to 2, but that whole portion was unit elastic. I know conceptually it is a little tough to think about. Unit elasticity is a little bit tougher to think about than elastic, which is why, like I said, on the exam, things like that, I'll probably stay away from that a little bit more. A couple more minutes to make sure I mentioned a couple things for you. Yeah. So Friday, we'll kind of finish up. I'll kind of introduce 3 different types of elasticity. Cross price, I think we've got income and then supply. And then I've got this kind of slide that I left here. We'll probably work through an example together where we talk about it. We'll kind of go back to where we were before elasticity. Right? And there's a reason why, because I need to set up the next thing we're going to talk about. So when we have a visual of like supply and demand, we said the equilibrium is wherever those two intersect. Right? Well, because I'm going to keep demand linear, and we'll have some equations that actually represent demand and supply, we can use those equations to also come up with the values for what the equilibrium quantity and price would be. So we've already done the visuals. We're going to kind of go back and kind of add to those, and how do we do it mathematically with the actual formulas. Right? So we'll finish up elasticity, and we'll kind of jump into some more math-intensive things, and then we'll start to talk about the government screwing things up. But that might have to hold off until early next week. Okay? All right, so start working on that second homework, and I'll see you guys on Friday.
Okay, 1 second. Before you get rid of that second question.
Yeah.